Question 7. So the key thing here is to spot that this is we're able to convert this into a quadratic by a substitution. This first term is still a squared term of the second term. So if we choose to let k, say, equal x to the half, then obviously this is 6k, but x is x to the half times x to the half, which is k squared. So basically, if we choose to do this, this equation can be thought of as being k squared minus 6k plus 2 equaling 0. Now clearly that can be solved. That's a proper quadratic as we know it. So if we can solve this by completing the square, so just taking the first two terms, halve the coefficient of the second term, minus 6 becoming minus 3, k minus 3 all squared would throw out a plus 9 at the end, which we do not want, so we choose to take away 9. So these two terms here have been redrawn as this bit here. This is the same thing in a different format. Still have the plus 2 on the end equaling 0. So gathering up the minus 9 and the plus 2 giving us minus 7, and then adding 7 to both sides gives us this. We then square roots, we get k minus 3 being plus or minus root 7, adding 3, k equals 3 plus or minus root 7. Now remember, k is just something we've invented. K is actually x to the half. So it's not k being 3 plus or minus root 7, it's x to the half being 3 plus or minus root 7. So squaring both sides, x equals 3 plus or minus root 7 all squared. So let's look at each of these in turn. So let's start off by doing 3 plus root 7 squared. So 3 plus root 7 times 3 plus root 7. Multiply out, we get this, which simplifies to our final answer of 16 plus 6 root 7. So that's our first final answer. Our second value comes from 3 minus root 7 all squared, which I've looked at here in black. 3 minus root 7 times 3 minus root 7. Again, multiply out, we get this, which simplifies to 16 minus 6 root 7. So those are our two values for x.